So what I want to do for the second part of the tutorial is let the animation play out for a few complete cycles at real speed, and then what we're going to do is slow it down, and we can run things frame by frame. We can move forward frame by frame if we want, and we can also retract frames so we can really understand what's going on with these components. So here I'm going to let it run. You'll see the cylinder extend and retract and extend again and retract. And notice it's not just the cylinder that's moving. The gauges are moving, the directional valve's moving, the pump's moving, the relief valve's moving. There's a lot going on there in this simple circuit. Okay, so hopefully that gave you a good idea of how it all works, but now let's look at it in detail. So when we start here, what we see is we've got a spool that's in the center position, pressure is blocked right here, and we see our relief valves open, right? Our relief valve here, the poppet's off the land, allowing a flow path from 1 to 2. So now I'm going to advance it, and there at that point this spool shifted to the left, and that's when things start to get interesting. So now you've got an alternate flow path for the pump to move oil to. Instead of just going over the relief valve, now it's going to fill this void across our directional valve spool, and flow is going to start to head into the A port, out of the A port of the directional valve into the piston end of the cylinder. So now I will advance it again, and you see at this point between those last two frames the relief valve closed off. So now the pressure here, it's easier, the fluid takes the path of least resistance, which in this case is into the piston end of the cylinder. So at this point, what do we want to look at? Well, for one, the red is indicative of the higher pressure, blue is indicative of the lower pressure, and there are varying colors in between that represent the intermediate pressures. But at this point, this cylinder here is going to start to extend because we've got pressure going into the piston end, we've got a pilot pressure here, and it doesn't look like our counterbalance valve has shifted yet because we still have high pressure on the rod end. But if I advance it another frame, there, at that point you could see it shift. So between those last two frames, if we look at the counterbalance valve, we'll go back and forward, back and forward. So that opens up this flow path between 1 and 2. So we've got flow going from P to A into the piston end of the cylinder. We've got flow trying to come out of the rod end of the cylinder. Now it's got a path over the counterbalance valve from 1 to 2, and now it can go into port B and ultimately to tank. So we've got a complete circuit. So I'll let it play a few frames here, and that's more of a steady state type position at that point as it approaches the end of travel. And I'll run it a couple more frames, and when it gets to end of travel, you're going to see a pressure spike here, because all of a sudden what was a wide open flow path is going to shut off because our actuator or cylinder is at end of stroke. So right there you saw the gauge kind of peg up right there. So at that point what's going on, we still have our directional valve shifted, so P is ported to A here, and we still have a pilot pressure at our counterbalance valve, so that's still open for the moment. Now another interesting thing between those last two frames is we see our relief valve open back up again. So I'll go back a frame, and you see the relief valve was closed when things were moving along, and then I advance it, it opens up again. So I'll go back again and advance, back and advance, so you can see that relief valve opening up, because now all of a sudden the only way this pump can relieve itself is to elevate its pressure to the setting of this relief valve and go to tank. So now our situation, we have a pump that's going over relief again. We still have a spool shifted. We have a double acting cylinder that is completely extended and not a stroke. So if we advance this again, the next step will be to change anything. We need our directional valve to change positions. So if I advance it a frame, now this went back to the center position. And if you recall, in our center position, A and B go to T and P is blocked. So now we're back at center. And when that happened, if you look at this, suddenly the red went to the blue again. See, if I go back a frame, when this was shifted over, this was exposed to pump pressure. Now, when I shift the spool, all of a sudden A is going to be vented, if you will, back to tank, but P is still going to be at the high pressure. So at this point, although we've shifted our spool back to center, still all of our pump flow is going to be going over relief because there's nowhere else for this pump flow to go. Okay, so the next frame is actually a spool shift to the other direction. So this is to the right. So this correlates with this spool position, P crossing over to B, A crossing over to T. P is crossed over to B. See, this spool came off its land and opened up that little bit of a flow path right there. There will be a decent pressure drop across the spool depending on the design. There's a lot of factors that affect that. But for now, the takeaway is that a flow path opened from P to B, and now you're putting flow into port 2 of the counterbalance valve. So P to B, if we go back to the schematic, now you're putting flow into port 2 of the counterbalance valve. Now this, when you're moving flow this way, 2 can go to 1 right around that free flow check valve. We talked about that in part 1 of the tutorial. So flow from B to port 2 is going to go right around this free flow check and into the rod end. Same thing here. It's going to go right around here from B to 2. Over it, it's going to make this free flow check, pop it, come off its seat, and it's going to come right over to port 1 and into the rod end. So I'll advance it a frame. If I go back a frame, you can see this poppet. It's blocking the path right there. But now, if I advance it a frame, you can see it move. See? Back and forward. And now if I keep advancing, what's going to happen? Well, our relief valve closed off again, and now our cylinder is going to retract. So this is what I would call a steady state position. I'm advancing it frame by frame, but our counterbalance valves, the flow path is open from 2 to 1 via that check, and oil in the piston end of the cylinder has an easy path back to tank. One area I don't want confusion. It seems like that this path here, the blue and the red, intersect, but they don't. You have to envision these being two different drill paths and not intersecting each other. So the red P does not intersect with the blue tank flow there. So if I keep advancing, it takes us back to the beginning of the animation where we started with the spool in neutral. So I hope that was educational. I hope that this made sense and that it helps you better correlate the schematic depictions to the real world components. These are somewhat simplified components, but they really do help you grasp the concepts of how these valves move and cylinders move in the real world. So thanks for tuning in.
A hydraulic press is a device using a hydraulic cylinder to generate a compressive force. The hydraulic press depends on Pascal's principle. This example will demonstrate how the Pascal's principle may be used. When force F1 acts on area S1, a pressure is given by. Pressure acts at every point in the system, which includes surface S2. The attainable force F2 is given by The basic principle in hydraulic is Pascal's law. The effect of a force acting on a stationary liquid spreads in all directions within the liquid. The forces are in the same ratio as the areas. The forces F1 and F2 vary proportion to the areas of the pistons. The displacements L1 and L2 of the piston vary inverse proportion to the areas. The check valves 1 and 2 are valves that normally pass fluid through it in only one direction. How does the hydraulic press work? Hydraulic pump is driven by electric motor. Pump sucks fluid from tank and pushes it into the lines of the hydraulic circuit through various hydraulic devices up to the hydraulic cylinder. The direction of movement of the piston in the hydraulic cylinder is controlled by a directional valve. Hydraulic cylinder at the end of the line represents a resistance to flow. Pressure therefore increases until it is in a position to overcome this resistance, until the piston in the cylinder moves. So that the hydraulic circuit is protected from excess pressures and hence from overloading, the maximum pressure must be limited. This is achieved using a pressure relief valve. The flow still delivered by the pump flows via pressure relief valve directly back to the tank. The pressure at this moment is maximum. The direction of movement of the piston in the cylinder is controlled via directional valve. The cylinder returns to its starting position. Let's see how the hydraulic press works again.